Our learning target is I can use the periodic table to write and interpret electron configurations. So we're going to learn how to do a shorthand electron configuration and then determine the identity and the family of the element from its electron configuration. So remember that an electron configuration is a map of the electrons in an atom. Now there's some steps, so you can pause the video and write these down. We're going to locate the noble gas that precedes the element. Put that symbol in brackets. Then we're going to account for all of the electrons in the row up to the element. We're going to use coefficients in front of our sublevels. So S and P, the coefficient is the same as the row number. For a D sublevel, it's row number -1. The top row, the lanthanides, are always going to be 4F, and the bottom row, the actinides, are always going to be 5F. So there is a pattern to the periodic table. So all of the alkali metals end in S1. All of the alkaline earths end in S2. Then we get to our transition metals, and these are Ds. Now remember that the energy level will be the row number -1. So because we're in the fourth row here, this would be 3D1. Then our P's are in this block. Remember that P and S have the same coefficient. It's the same as the row number. So here are the row numbers. And then down here, we're in row 6 because these guys actually fit in right here. And we're in row 7. These guys fit right here. So these are 4Fs and 5Fs. So for sodium, our noble gas is neon. All right, sodium is number 11. If you look on your periodic table, neon is 10. Sodium is in the S1 column, the alkali metals, and it's in the third row. So we're going to say that its electron configuration is 3s1. Now to double check to make sure we have this right, neon has 10 electrons. We get that from its atomic number. So 10 plus 1 is 11, which is what sodium is. For sulfur, it is in the 16th column, the chalcogens. So the noble gas that comes before that is neon as well. And then we have to fill up the row up to sulfur. So let me pop back to this slide. So sulfur is right here. Okay, so we have to account for these 2s electrons and then our p electrons till we get to sulfur. Remember that our noble gas in brackets accounts for that many electrons. So putting neon in brackets accounts for the first 10 electrons. So for neon, our first 2 after 10 go into 3s2, and then 3p4 finishes us out because sulfur is in the p4 column and it's in the third row. For manganese, it's number 25. So argon is our noble gas. Our next two takes care of 18 electrons. Our next 2 electrons go in the 4s2. Can you notice that there's always an s that comes after the noble gas? And then manganese is in the D5 column. So remember that D's are row number -1. So that's going to be 3D5. So if we count 18 plus 2 is 20, plus 5 is 25 for manganese. For tin, that is number 50. So it's in the 5th row. Krypton is our noble gas that comes before it. That's 36 electrons. So then our next 2 electrons would enter the 5s2 sublevel, and then we have to go across the 4d10, and we're filling all of these up. We have to go through the row, and then we get to 5p2. And when we add all those up, it gets to 50. Now let me go back just really quickly. All right, so 10 is right here. Okay, so our noble gas there was our krypton. So then we fill up 5s2 and 4d10 and then 5p2 until we get to 10. Our next example is barium. It's number 56. It's in the 6th row. So the noble gas that comes before it is xenon. It takes care of 54 electrons, and barium is in the alkaline earth metals, so column 2. So it's going to be 6s2. It's in the 6th row in the s2 column. All right, now try the electron configuration for lead. Pause the video and try it. Most of you probably got this answer here, 6s2, 5d10, 6p2. But when we count these and add them up, xenon is 54, plus 2 is 56, plus 10 is 66, plus 2 more is 68. Well, lead's atomic number is 82. So 82 minus 68 is how many off? It's off by 14. So what we have missed is our F sublevel. So what we have to remember, I'm going to speed back through this, is that these bottom 2 rows here actually do go in right here. Alright, so anything in row 6 or 7 that are past the S2 column, we have to insert the 4F and the 5F. Okay, so make sure you double check and count, because if you're off by 14, that's a pretty easy fix. So our 4F14 does go in after the 6S2. So our electron configuration for lead should be 6s2, 4f14, 5d10, 6p2. So platinum, its electron configuration, xenon is the noble gas. It's in the 6th row, so 6s2. Don't forget that 4f14 comes after the 6s2, and then 5d8. It's in the d8 column, and it's a remember that D is row number -1. So practice these electron configurations. Pause the video because the answers are getting ready to pop up. Now, if you're in honors or you just want some extra information, and you might see this on a bonus question if you're not, we do have to do these lanthanides and actinides down here. So notice what happens. Remember, these are supposed to be right here in row 6 and 7. So the first thing we have to do is account for a D1 and then a 4F. And this seems to, break the Aufbau principle, but this does happen in certain exceptions. So for uranium, which is right here, our noble gas that comes before it, this is in row 7, okay, so our noble gas that comes before it is radon here. So 7s2 comes next, then we have a 61, and then it moves down into the 5Fs, and we count 1, 2, and 3 for uranium. Gadolinium is number 64, which is right around here, I think. Alright, so that's in the 6th row. So our noble gas is the one in the 5th row, which is xenon. Then 6s2 gets filled first, then the 5d1, and then the 4f7.